Hello everyone, this is overflowStackDeveloper, and in this video series I'll be taking you through system design for YouTube. So just to recap what I did in my previous two streams, we understood a rough architecture of YouTube. तो वो लोग क्या करते हैं जिसमें एक यूज़र होगा and they will upload a video raw footage and it's going to be stored in a blog, something like not S3 but GCP uh, storage bucket, and then it's going to kick off a transcoding pipeline जिसमें हमारे पास तीन चीज़ें होती है. First we create multiple resolution for that uploaded video, and then multiple codecs and multiple containers or segments. Then Google has its own network of CDN जिसमें what they do, they push the data to a server which is physically closer to the user so that it reduces the latency, and then the end user views the video and the decoding takes place. And apart from this, YouTube has other components which is searching, recommendation, YouTube Studio. So this is just a rough overview. If you look at the uploading process, they also check copyright strikes and other things like that. For example, managing metadata for each video, such as like, share, subscribe, counts, etc. So I've covered all these things in my previous tutorial. So in this live session, I will keep things very simple and minimal. Okay. So in this tutorial, I'll be showing you how to use Claude Code to learn software engineering. So if you're someone who doesn't know system design for YouTube or any other application, uh, you can just come here, write a prompt and get all the answers you want. So it's a really amazing tool. It makes learning much more faster because you're not going through multiple web forms looking for answers. So in this live session, let's look at what are some interview questions that you can encounter for a system design interview if the topic is YouTube or any other video sharing platforms such as Netflix, Amazon Prime, etc. So what I'll do, okay, I'm learning system design. Give me 3 interview questions that can be asked for freshers. System design for YouTube. So let's see what do we get. Okay, so the first question is, how would you design the high level architecture for uploading? Test basic understanding of and server flow, storage of video. So it's going to go, and then we have the metadata, simple request handling, no skill consideration needed yet. Why can't you just store video file directly, and where should they go instead? Test whether the candidate knows the difference between blob storage and relational metadata. And then what happens when a user hits play on a video? Walk me through. So there's a group of CDNs and they are extremely close to the end users. So the diagram which I showed you in the beginning, so these questions revolve around that rough diagram. So I'll say, okay, also give me the answer to these questions. So high level architecture for uploading a video. Let's use a record or select a video and upload it. Then we have the upload server receives the video file and metadata. and stores the actual video file in something like Google Cloud Storage, and the database only stores the metadata and the URL pointing to that blob. Playback services slash CDN, the server the video files back to viewer efficiently. So this is the flow. Now the next one is the key difference, the key idea for a fresher level answer is separate the big binary file from the small structured data about the file. Why not store video file directly? Size mismatch. SQL database are optimized for small structured row. Video can be gigabytes. Storing them in blob loads the database, slows down backup, indexing, and replication. Especially with fast SSD backed storage for query are expensive per GB. Then we have the scalability issue and then access pattern. How are you going to perform where and join operation on videos? Where it should go instead, they go in a Amazon cloud storage or Azure blob storage, and the metadata and the pointer URL to the file in the blob storage. SQL or no SQL. This separation fundamental pattern. Store large unstructured blob. And what happens when a user hits play on a video? Even I don't know this, but I think decoding takes place. Give me the video with ID X. Server looks up metadata, checks the video exists, is public, available, get the storage location, URL of the video, and the server responds with the video metadata and a link URL to fetch the actual video content. Often a CDN, not the raw storage file. Player requests the video content from the URL video, and the video is streamed, not downloaded all at once. That is probably sent in small chunks. The player fetches it in chunks using some HTTP range request, so playback can start before the whole file is downloaded, and user can see to a different part of the video without downloading everything first. Video isn't sent as one giant file transfer, it's streamed in small bits. It's used to make that fast and scalable. Okay, so let me write down these questions for fresher level. So the first is, how would you design the high level architecture for uploading and viewing a video? How would you design the high level architecture for uploading and viewing a video? Fine. Then the next question is, why can't you just store video files directly in a SQL database? Why can't you just store video files directly in a SQL DB, and where should they go instead? Okay. And then what happens when a user hits play on a video? What happens when a user plays on a video? Fine. So on a high level, we have the user who uploads the raw footage, and from here then we have the upload service, probably API. Then it is stored as a blob, something like S3 or Google Cloud Storage, and from here, since the user uploads the raw footage with metadata such as title, description, language, things that pops up when you're uploading a YouTube video. So in the DB we write the metadata plus the URL to the blob. and then we have the playback service or the content delivery network. So whenever you request a YouTube video, it only returns the metadata plus the URL pointing to the video file. So now since there are multiple resolution, how it decides which one do you want based on your playback settings. If you have selected 4K, 144p, whatever. Separate the binary file from the small structured data about that file. Why not store video files directly in the database? So it's pretty straightforward. Costs, storing large file requires a lot of memory. Then you have the efficiency issue. Searching, indexing, becomes difficult and slow. Then we have the size mismatch. Database are meant for smaller structured rows, typically numbers and strings. And then you have the access problem, um, how do you perform joins or where having clause, things like that on a video file. I don't know if you can or cannot perform. You cannot perform join where or having clause on video files. Now the third question is what happens when a user hits plays on it. So the client sends request to the backend. Okay. So the client sends video ID to server, and from here the server fetches the metadata and the link URL. Server I think it probably goes to the server and from DB get metadata and video URL, not the raw footage but the CDN one. And then this is the most important part, which is the video is streamed and not downloaded, so that the user doesn't have to wait to watch the video after downloading. Okay, so these are the three questions for fresher level. Let's see what it will give me for 3 years of experience. Give system design interview question for 3 years of experience. I'll say YouTube system design interview question along with solution. So design the video upload and processing pipeline with transcoding. Okay. A user uploads a raw video file, design the backend flow so that it becomes available for streaming to millions of users on different devices and networks. Support large file upload, convert video to. So this is going to be tough because for 3 years of experienced developer, they just don't want to know that it's not sufficient to know that you know the concepts, but also you should be aware how to implement those concepts. So now they are asking to implement the entire transcoding pipeline. Once raw file lands in S3, write a row. So this is almost design the video streaming playback path at scale, CDN plus adaptive bit rating. Watching video concurrently on different networks, 3G to fiber. Design how video is delivered efficiently. Adaptive bitrate streaming. Video is pre-encoded into resolutions and split into segments. A manifest pilots available solution segments. Monitors network bandwidth in real time and requests the network chunk at the resolution that fits current bandwidth. So typically sometimes when your internet is running slow, even though you have selected 4K as an option, what YouTube typically does, it reverts to lower resolution for smoother streaming, even though you never intended for lower resolution, just because of your adaptive bitrate streaming, which monitors your network bandwidth. Then CDN in front of origin storage. Design the view count and comment system at scale. Woohoo! So how do you track and display view counts and comments for videos? Give some videos get millions of views per hour. Incrementing a dB counter every single view for a viral video causes massive write contention or throw problem. So each app or server edge node increments a local in-memory counter or writes to a lightweight message queue instead of directly hitting dB per view. So these are meant to test whether a 3-year of candidate can reason about asynchronous processing, caching, CDN. Okay, so let's start with question 1. 3 years of experience. The first one is design the video upload and processing pipeline, which is with ask a user uploads a raw footage, design the backend flow so that it becomes available for streaming. Architecture. Okay, so instead of writing this blindly, what I would like to do is uh, accelerate draw. Now let's use this. Let me clear all these things. Support large file upload. So in order for us to design a very smooth transcoding process, first we should be able to handle large files, which can be in GBs. Then we have to convert it into multiple resolution for adaptive bitrates. Should not block the user. Upload should feel fast even though processing takes time. Fine. So So the requirements to make the uploading plus transcoding process at large scale, we need to keep in mind we have to support large video files ranging from few GBs to 100 GBs. Then we need to tackle the problem of converting the raw footage into multiple. Convert the raw footage to multiple resolution and formats, and then should not block the user for uploading. It means if you have ever uploaded a video on YouTube, typically what happens, even though your footage has uploaded successfully, in the background it will start performing the checks for copyright or other necessary things while you're free to do other tasks. So it should not block the user while they're uploading the video. Okay, so now the requirements are clear. Break file into chunks, upload parallel so large files don't fall on network drops. Use resumable/chunked uploads, and client uploads directly via a pre-signed URL. I have no clue what this means. Pre-signed URL issued by the backend, avoiding routing huge files through the app server. Then we have, once raw file lands in S3, write a row to DB video ID status uploaded raw file location, pushes a message to the queue or SQS in AWS, new video ready for processing. And then we have a transcoding service, async worker pull. Worker pick up the message, pull the raw video from S3, splits into video into chunks, and transcode each chunk in parallel across multiple resolution. Okay, so probably these steps in themselves are really complicated. I'll try to simplify this. Um, okay, so I have the client upload service. Now in this, okay, use resumable chunk upload, fine, breaks into chunks, upload parallel. So here what I'm understanding is that uh, the raw footage is broken into various chunks. C1, then we have C3 and so on. Okay, now I have these chunks. I'll say raw file broken into smaller chunks, and then from here they are all uploaded in parallel. And I think again the so large file are so large file don't fail on network. Okay, that's fine, but if you're breaking them into chunks, you also need to reconstruct them. Client uploads directly to blob vi pre-signed. I'll just note this point down and maybe write it later because oh, so it doesn't uh, the video directly goes to S3 block. So I think insert image. So we have a bucket S3 or GCS. From here, I will say uploads directly to via pre then we have once the file lands in the S3 writes a row to db. Okay, so once upload finishes, maybe there will also be a case when on success failure. I even though this is not mentioned in the prompt, but I do believe that there has to be a case where they also handle failure even for this process. For every process there's like two parts, success and failure. So on success, write to write to db, and after this will create a row, write db, and then video id is populated, status is equal to uploaded, and then we have the raw file location. Publish a message to queue. Okay, so once publish a message to queue, new video ready for processing. Okay, so after the success, we have a Kafka or SQS. When the worker picks up the message, pull the video from S3. Worker picks up the message, pull the raw video from S3. Uses a framework like direct a cyclic graph-based pipeline in code, generate thumbnail. YouTube can process a 2-hour video quickly, parallelism at the chunk level. Okay, so here transcoding begins. Transcoding. Transcoding begins. Now worker pick up the message. So I'll just write in pointers instead of drawing any diagram. First, multiple workers spawns. Then they pull the video from the then we split the video in chunks and transcode each chunk in parallel across. Okay, split the video in chunks and transcode each chunk in parallel across multiple resolution and codec. So this is why YouTube can quickly process parallelism. Use a framework like that. Store all transcoded variants back in S3. List of available resolution. Okay. Then DAG based pipeline encode, generate thumbnail, generate caption preview package for streaming. No clue what this means. I'm just blindly writing this. Probably one day I'll figure this out. Um, encode, generate thumbnail, package for streaming. And then again store. Okay, notification when processing is done via webhook or push notification the video is live. Key trade-off to discuss: while async processing, uploading shouldn't block contrast, bad UX and transcode take much longer than upload. Why chunk reduces processing time from linear to near constant. Worker crashes mid-job, uses checkpointing so it doesn't reprocess from scratch. So I think when transcoding fails, probably there is some system in place which resume from the point of failure instead of starting from the beginning. Okay, not every video needs every resolution instantly. Can transcode first 1080p, Q lower quality resolution, progressive availability. So I think this is a very good point which I'm not aware of. Let me write a note over here. Uh, Not every video needs every resolution instantly. Can transcode 10 first queue lower priority resolution later. So 1080p is pretty decent and most of the device supports this. And once this is ready, then probably it picks up the higher resolution and the lower resolution. Okay, so I have a follow-up question regarding this. So I have three questions. Uh, the upload process is broken into chunks. So when are the chunks reconsolidated? Second, what happens if writing to DB fails? Or third, what happens if some chunks fail to be encoded? And what else? Third, what happens if the raw footage fails to be uploaded as blog? So they are actually two different chunking steps. Oh my god, bro. Now what your diagram shows, this is just splitting the raw file to transfer it so upload is presumably parallelized over the network. Byte range pieces are the same if not separate encodable units. In S3, most objects support multi-part upload, where each chunk is uploaded with an index and once all processing. Okay, maybe you know what I'll do. I'll note all these points down because the problem is if you ask it any question, it's going to give you a detailed explanation, and then every detailed explanation will probably take you a lot of time to understand. So the upload runs often into chunks. So when the chunks are consolidated, what happens if some chunks fail to be encoded, fails to be uploaded as blob? What happens if right into looking at your diagram, there's 3 upload already succeeded by this point, so the risk is having an open file in drops, which is bad because the video is invisible to your system, but it silently consumes a leak and storing dangling reference to client thinking uploads. Retry with backoffs. DB write failures are often transient, connection blip, replica lag. Use video ID generate client side or by the video service. क्या है write DB row before upload, not after. Okay. A common alternative path. What happens if some chunks fail to encode? This is a partial failure problem in the trans and it needs to be handled per segment, not per video. Okay, so I think every chunk has a status. If it fails, then it'll be reprocessed. Retry the failed chunks only. Poison pill. If a specific chunks fail repeatedly, move it to a dead letter queue after n tries rather than retrying forever. Flag the video for manual review. Partial availability. You can mark a video available for playback once minimal viable sets is ready. Fail to be a, this is a left branch failure path in your retry the chunk level first. Damn. Okay, design the view count and comment system at large scale. So here so this is question 3. Design the comments are write, moderate, read heavy. Store in a scalable NoSQL. Okay. Strong consistency versus eventual consistency. Incrementing a DB counter on every row will make it the hot row problem. Each app or server has to increment a local in-memory counter and then writes to a lightweight message queue instead of directly. Use pagination cursor based, not offset based, to avoid performance degradation on deep pages. Comment counts follow the same batch aggregates, don't increment. For top comments, most like maintain a separate sorted structure, sorted set in Redis per video rather than sorting on read. So to summarize the solution of problem 3, I can say no need, do not increment db counter on every single view. It will cause massive write contention. Massive write contention, or also called hot row problem. So each app or server, each server increments a local in-memory counters or writes to a lightweight message queue instead of, or writes to a lightweight message queue because you do not want to hit the DB again and again. And then a streaming process job aggregates the count and then update it. Then a stream processing job, Flink, stream processing job, something like Kafka consumer or Flink. Why can't we just use a regular cron job for this? Which I don't know. What is stream processing job and why can't a cron job do the task of updating the count of videos? So they aggregate the count and batches the updates to the DB. I think for comments also they use the same logic. I'll say views and then I have the comments. So comments are right moderate because if you look at every YouTube video, probably let's just say that it has 1 million views, then the number of likes might be like 400,000, let's just assume, and then number of comment will be like 200k or something. So this is the pattern that's always observed for any social media platform. That is, the number of comments will always be less than the number of views because you cannot comment on a video that hasn't been viewed yet. So comments are write moderate and read heavy. So they are typically in a NoSQL database keyed by the video ID, sorted by timestamp. That means that is fetch the latest comment. Is a simple partition scan. Use pagination, fine. The comment count follows the same logic as view count. And for top comments, so yeah, this one, for top comments or the most liked comments, maintain a separate sorted structure, sorted set in Redis per video rather than sorting on the separate sorted structure. So I think this is enough for today, and in my next video I'll cover system design question for YouTube for experienced developers.